He is a man in the great wild. Here this bloke is demonstrating potential energy. So you ask what potential energy is, do ya? Well, potential energy is the energy an object has while not in motion. A good example of this is a rock sitting on a cliff. Oh, look out, there's a rock sitting on a cliff. Oh, watch, the young buck is on the move. He just turned his potential energy into kinetic energy, which both units are being measured by joules. Oh my goodness, the rock is turning potential energy into kinetic, and it's coming at our boy. Look out! Yow! Well, that had a whole lot of power behind it, didn't it? It technically has power, but power is just energy. Power is the amount of energy in an object to displace another object, while work is the energy required to displace an object, and work is measured in joules and can be measured by force and displacement, while the units of power are watts. Wow, that bloke is flat into a pancake. Let's hope he doesn't cook up in this heat. I wonder if that concrete's hot enough. Let's hope it isn't 55 Celsius, because he will burn up real good. Now that I think about it, how does heat work? Heat is just kinetic energy transferring into the concrete. The first heat introduced was transferred from the sun. The heat from the sun is just energy. The sun contains a whole lot of energy, 44 quadrillion watts to be exact. You didn't answer my question, mate. Don't worry, I'm getting to it. So the sun sends radiation waves that transfer heat through electromagnetic waves through solar radiation. Solar radiation energy travels through a 93 million mile vacuum to warm the Earth. Well, then why is it brighter in Australia than here? Well, there's a couple reasons why. Two of which are that you're closer to the equator and that you're on the southern hemisphere. So when your summertime rolls around, you're closer to the sun. The watts sent into the air are a source of energy that can be used as heat. The energy is transferred to us and also into the concrete that Owen was flattened on. Radiation is why that heat can make its way from the sun to the earth, and convection is a type of heat that rises. Convection could have been happening to Owen, which could have been cooking him, while conduction is molecules transferring kinetic energy from one another throughout different collisions. Well, after a certain temperature, water turns into ice, so a liquid turns into a solid, right? So conveniently, it's nice and cold out. So watch. Water can not only turn into a solid from colder temperatures, but it can also be turned into a gas in hotter temperatures. Have you ever wondered how the sun emits light? Now that I think of it, I haven't. Well, light is actually made up of waves. One important property is the wavelength, which is the distance between two consecutive points in the wave. Another property is frequency, which is the number of waves passing a point in 1 second. The amplitude is the height of the wave, and it represents the brightness or intensity of the light. Higher amplitudes mean brighter light, while lower amplitudes mean dimmer light. Well, how does that make the sunlight travel to the earth? Well, light waves also have a constant speed in the vacuum, which is about 300,000 kilometers per second, and the vacuum that the earth and the sun share is space. This is where the waves travel through. Even us talking about waves uses waves. Sure they do, smart guy. Sound waves are a type of wave that travels through the air or other mediums, like water or solids. They are produced when something vibrates or moves back and forth. This can also be affected by the oscillation of the waves and can create different pitches in different people's voices. Is there different types of waves? Yes, there are. For example, longitudinal waves are like compressions and refractions traveling through a medium, such as air. When we speak, our vocal cords vibrate back and forth, creating waves. Even though transverse waves don't relate to speaking, they do relate to the light that comes from the sun. Sunrise! Yeah, but you can think of light as a transverse wave, with its electric and magnetic fields oscillating up and down perpendicular to its direction of travel. Finally finished my physics project. It was so easy. I just need to edit it, and then I'm going to wind down. Let's hop on some games. Well, let's run down some of the possible reasons why this happened. One of the circuits could have had too strong of a current and could have caused the circuit to overload. This means that it was carrying more electrical current than it was designed to handle. But before I explain some of the other possible reasons, I have to explain some of the other parts. An electron is a tiny particle that carries a negative charge. It's one of the building blocks of an atom. Electrons are incredibly small and they go around the center of an atom. You can't have electrons without electric field strength. Electric field strength tells us how strong the push or pull of an electric field is at any certain point. It measures the force that the pushes or pull charges. This is measured in volts per meter. Resistance. Well, resistance talks about how much material resists or slows the flow of electricity. It's like an obstacle that makes it harder for electricity to move. This all depends on different materials, and resistance is measured in ohms. So here could have been one of the other reasons why my computer messed up. It could have been because of a short circuit. When there's an unintended low resistance connection between 2 points in a circuit, it creates a pathway for a large amount of current to flow. This bypasses the normal components and it may cause some overheating and sparks and potentially some circuit damage. And that was my whole physics project, written, directed, and starred by Lewis and co-starred by Owen Lyland.